The domain and range of a relation just specify the set of all the inputs and the set of all the outputs, respectively, in a relation. Whenever I'm dealing with domain here today, I guess I'll use the color blue. So we'll define the domain to be a set, and it's a set of all of the inputs in a relation or an association between two different quantities. And then I'll just use, how about the color red for whenever we're dealing with range today. So it'll be the set of all the outputs in a particular relation. So using the example of the skydiver, this is the relation right here. And so in that particular relation, we can specify exactly what the domain of that relation is. So the domain is just going to be the set of all the inputs, basically just the x coordinates of the times. So it'd be all of these values right here. So because they're all separate numbers, use commas to separate each of the different elements. And then because domain and range are sets, we need to use proper notation to express these as sets. So since this is a set of a countable number of objects, we can use braces around that to express that as a set. And then the range is pretty much similar, it's just we're going to use the heights instead, so 10,000 and etc. Great, and that gives us the domain and the range. So just a few examples here that just gives us a good understanding in all four different representations, whether we're dealing with ordered pairs, a table, a mapping diagram, or a graph. So in this first example, it's exactly what we just did. We just found the domain and range of a relation when it was expressed in an ordered pair format. So just very clearly, these elements are all the x coordinates in this relation, so that's going to specify the domain of the relation. And then for the range, an important detail that you need to pick up right here is the fact that there is some repetition of the elements. So whenever you have domain and range that you're expressing, we don't care about the number of times, right, that an element appears in a set when we're representing a set. It's just making sure that we know that they're a member. So when I write the range right here, then I can just write -1 once, or not -1, +1 once, and then I just know that it's a member of the set. I don't need to write it twice, okay? All right, from a table, pretty clear here, because you just have 3, 5, 7, 8, 11 are the x coordinates, obviously going to be the inputs, so that gives you the domain of that relation. And then for the range of that relation, it's going to be the set of all the outputs. Notice again, you've got a couple of elements that are the same within the range set right there, so you only need to write that 7 once. And then from a mapping diagram, of course, these fellows right here are going to be the inputs. There are no repetition of elements there, so we'll just write all those numbers separately. That gives you the domain. And then the range is going to be these right here. Know that whenever we're representing relations, we don't always have to use numbers. There can be relations in which we represent relations between things that are not numbers. So like right there you have letters, of course, right? So A and C and E are different output elements belonging to the range. And then finally, if you're dealing with a scatter plot, you really just need to know what the coordinates are, and then just all the x's belong to the domain, of course, and all of the y's belong to the range. So if I label all of these points, so like this point right here has an x coordinate of 2, y coordinate of 4, this is 0, 1, over here is -3, 2, and down here is 4, -3, and then I can just list out all of the x coordinates. So these right here would be members of the domain. You don't have to write them in increasing order per se. I just happen to do so right here. So maybe I'll write this next one in random order. So if I did like 1, 2, -3, 4, it's not in any particular order right there. That's okay. You don't need to write elements and sets necessarily in decreasing or increasing order, although it's kind of nice to do so sometimes.